Hi everybody, welcome to lesson 1 for week 6 for year 5 maths. Today we are looking at balancing equations. Okay, so today we are learning to balance equations where a number is missing. So the first thing you'll need to understand is, what is an equation? Well, it's a number sentence that uses the equals sign. So let's say 5 plus 7 equals 12. This is a number sentence, but it's also an equation. So an equation is a type of number sentence that uses the equal sign. If I had 11 plus 3 is greater than 2, then this isn't an equation because it doesn't include the equal sign. It's still a number sentence, just not an equation. The next thing you'll need to realize or recognize is that the equals symbol means the same as. Now, this is a real focus for today's lesson. It doesn't mean the next thing that's going to come along is the answer. It means that this part of the number sentence is the same as this part. They have the same value. Next thing is making sure that both sides of the equation have the same value. So this side of the equation would be 12. I could write that as 12. And this side is 12. So they have the same value. It's 12 apples or 12 bananas or whatever you're talking about. They're the same value and they're connected by this equal sign, which means the same as. And lastly, you'll just need to fill in the missing values. So you're going to have some equations where the values are missing or the numbers in the equation are missing. You need to add those numbers to make sure that both sides of the equation are balanced. They have the same value. Okay, in this slide here, we've got a pan balance, and it usually uses this when you're measuring mass. So seeing how heavy one object is in comparison to another. And so on the left-hand side, you might put some blocks, and on the right-hand side, you might put some pencils. And what you try to do is try to get both of these pans to balance so that these arms here are parallel to the ground, and both pan is at the same level. They're level with one another. Now we can think about a number sentence in the same way. So today we're looking at a specific type of number sentence, which is equations. Now, if we assume that each of these orange balls here have the same mass, then this pan balance wouldn't be balanced. This side here would be heavier, so the pan balance would be lower, and this side here would be lighter, so it would be higher. So we'd have to try to balance it. So we could add 4 more balls. Now assume these green balls are the same mass as the orange ones. We add 4 more on this side, and we've just done a basically balanced an equation, and I'll show you how. So on this side here, we've got 6. It's on the left-hand side, and on the right-hand side, we had 2. Then we added another 4. Now we know that the equals sign means the same as, and we can think of the equal sign almost like a pan balance, that whatever's on this side here needs to be balanced the same as this side. So here 6 equals 2 plus 4, and I can also simplify this side over here to make sure this is true. So 6 is equal to 2 plus 4 is 6, therefore this equation here is balanced because this down the bottom is true. Okay, so here I've got another set of scales, and instead of having objects on one side, I'm going to have part of a number sentence. And I know that my scales are kind of like an equal sign, which means the same as. So whatever's on this side of the scales, this side has to be equal to that. Now, before I even start looking at the right-hand side, I'm going to solve this. So here, I know that 17 plus 5 is 22. And I actually have part of the number sentence or equation over here, I've got divided by 2. Now, one thing that people often make the mistake of is they see an equal sign here, and they go 17 plus 5 is 22. I've got my equal sign. The equal sign means this is the answer. Whatever comes after that is the answer. So 17 plus 5 is 22. I'm finished. I'll move on. and yet they've missed this whole part of the number sentence of the equation. So let's see if we can actually, if this is a true equation. So here I've got 22, and then on this side, I have to complete this operation by itself. So 22 divided by 2 is 11. Now I know that 22 doesn't equal 11. So that's not true. This is not a proper equation. So I need to go back to the drawing board. So I'm going to rub all this out. So on this side, I've got 22. So whatever is on this side has to also equal 22. Now I'm not very good with my division number facts, but I know that 22 multiplied by 2, so I'm going to use my knowledge of inverse operations, is 44. So if I know that, 44 divided by 2 is going to equal 22. And now my equation is balanced. Both sides of the equation equal 22. So please, this is one of the reasons why I'm focusing on it this week, is I keep on seeing people making this mistake where they think this means this is the answer, and there's only going to be, I just need to fill in this space with whatever the answer is to this part of the number sentence, and I'm done. And they're missing this whole part here. So make sure both sides are balanced, and you need to read the whole number sentence, everything up until it finishes. Okay, let's look at some number sentences now, or equations. So we know our equations are number sentences with an equal sign in the middle. So whatever is on this side here, whatever this adds up to, this side has to add up to the very same thing for it to be balanced and for it to be true. So because I don't have any missing values on the left-hand side, I'm going to complete that side first. So 16 plus 4 is 20. So whatever's on this side here also needs to equal 20. That way I'd have 20 equals 20, which is true. So basically I'm just finding the difference between 20 and 2. So I could say that 20 minus 2 is 18, or I might also know that 18 plus 2 is 20. Now we have an equation where the value is actually missing at the front. So usually when we read a number sentence, we read it from left to right this way. But I can't complete this part first. I need to look at this other side here because this side doesn't have any missing values. So 18 plus 3 is 21, because I know that 18 plus 2 is 20, so it's just going to be one more than that. So here, something minus 9 equals 21. And what I can do, I can use my knowledge of inverse operations and just add 9 to 21, which I know is 30. Or I might also know that 30 minus 9 is 21. All right, now we have a longer equation where this first part, it doesn't have any missing values, and this side, the first value is missing. Now, I'm going to do this side first because there's no missing values. So 20 minus 4 is 16. And on this side, I actually have these brackets, which mean that I need to do that part of the number sentence first. So 4 plus 4 is 8. So something times 8 is 16, and I know that is 2. So now both sides equal 16, so this number sentence is true. 16 equals 16, that is true. And the last one here is a little bit different. Now, you won't have any of these today, but you have 2 missing values. So here I've got 8 plus something equals 5 plus something. So it's not simply a case of going, well, I'm going to solve this part first, and then that'll tell me, what I need to input here. So let's say I do 8 plus 10, which is 18. On this side here, so that's 18. This side here is also going to need to equal 18. So I could say 5 plus 13 is equal to 18. But also I could say, well, do you know what? Instead of 10, let's do 11. So 8 plus 11 is 19. Therefore, this side here also needs to equal 19. So instead of 13, it would be 5 plus 14. So it doesn't really matter which values I put in here, as long as this sum here and this sum here are the same. so it's balanced. So you've actually got an infinite number of possibilities there that you could keep inputting numbers. As long as both sides balance, it's completely fine. Okay, here are the main ideas from today's lesson, and these are sort of the main ideas that will carry you through the rest of the week as well, because they're so important. The first one, really fundamental, is that the equal sign means the same as. It does not mean whatever comes to the right of this is the answer. So let's say we've got 10 plus 4 equals 14. What this number sentence or equation is telling me is that this side here is balanced to this side. They are the same. They're both 14. It's not saying to me that, oh, whatever comes after this thing here is the answer. Because I could have a situation like this where it's 14 equals 10 plus 4. It's not saying the answer to 14 is 10 plus 4, because also I can have other combinations. I can have 6 plus 8. It's just saying that both sides of the equation are balanced. So that's really important to remember. And an equation, I've been using that a lot today, is just a number sentence with an equal sign in them. That's all it is. Both sides in an equation separated by the equal sign must always balance. That's what we've been looking at today. So 7 plus 5 here is 12. And 14 minus 2 is 12. So this is an equation and it is balanced. Now here, when both sides of the equation separated by the equal sign must always balance, this includes everything on either side of the equation. So here I've got 6 plus 7, which I know is 13. Now I'm not going to fall for the trap where I'm like, oh, yep, and the answer here is 13. That's not what this means. The equal sign doesn't mean that. It's saying everything that follows after here is going to equal 13. So I know that instead of 13 here, I'm going to put 10, because 10 plus 3 is 13. Now my equation is balanced, it is correct, and I'm good to go. And lastly, while we're doing missing values, complete the side of the equation without the missing value or numbers first. So in this case of 6 plus 7 equals something plus 3, I do the 6 plus 7 first, and that will help me figure out what is the missing value on this side here. Okay, thanks for listening to today. I'll see you tomorrow in lesson 2. Welcome to lesson 2 for year 5 maths for week 6. Today we are looking at inverse operations. Okay, so today's lesson, you're going to be learning to use inverse operations to solve equations. And we know an equation is a number sentence with an equals sign in it, which tells us that whatever's on this side of the equation is the same as or equal to this side here. To do this, you need to be able to identify the inverse operations. So the main inverse operations that we use those, and then show your working out. Now this last point here is probably the most important for today's lesson, apart from obviously being able to identify what an inverse operation is, because a lot of the equations we have are fairly simple. So you might be like, well, I already know the answer to that. That's not really the purpose of today. Today it's going, well, okay, I know what the answer is, but how can I justify that? How can I give evidence of that by using an inverse operation to also show how it could be true as well? So it's showing your knowledge of inverse operations is the most important part of today's lesson. Rather than just finding the answer, it's showing your knowledge and also showing your working out. This is particularly important going forward, as particularly as we go into kind of high school maths, where we're not looking so much for what is the answer, but how we can represent the answer, because the answer might not just be a single number. The answer might be an equation, with some unknown values in there still. But we need to be able to show our working out to kind of get to that level of mathematical thinking. So moving away from arithmetic and arithmetic thinking, more towards what we call algebraic thinking, where it's representing relationship between numbers, and sometimes in our equations we have unknown values even at the very end. So before we start, let's look at what inverse operations are. So this word inverse just means the opposite. So here we've got our 4 main operations that we use in maths. Now there are other operations, but these are the 4 foundational ones. So they're kind of like the big 4. We've got addition, which is the plus sign, and subtraction, which we know by our minus symbol. We've got multiplication by the times symbol and division by the divide sign. And some of these operations have an inverse relationship. So we know that addition and multiplication are kind of related because we have multiplication. One way of thinking about it is like repeated addition. Same with subtraction and division. They're kind of related because subtraction can be thought of as repeated subtraction. But let's look at just the inverse operations today. So it's quite simple. There's only really two. We've got addition and subtraction have an inverse relationship, which means they have the opposite relationship. So let's say we've got 4 plus 2 equals 6. So here I've got my total or my sum. If I do the inverse operation, starting with the sum here, so I've got 6 minus 2, it's going to take me back to the start, which is 4, which is where I started off from here. So subtraction is the opposite, the inverse of addition. Same with multiplication and division. So often you might hear me say that division undoes multiplication. So let's say we've got 5 times 2 equals 10. If I start with my product, which is 10, and I divide it by 2 instead of timesing it by 2, I'm going to end up with a quotient of 5. So I'm back to where I started from, which is 5. So the division in this sense undoes the multiplication, and it has an inverse relationship with the multiplication operation. Okay, so let's look at this addition equation. Now I could go ahead and just solve it and say, well, 80 plus 10 is 90, plus another 6 is 96, so my answer is 96. That's not really what we're looking at today. What we're looking at is seeing how we can apply an inverse operation to this number sentence to represent it in the inverse, the opposite. So I know that the inverse operation of addition is subtraction. So what this is going to become, instead of 80 plus 16, it's going to become something minus 16 equals 80. So what I've actually done is I've moved this number here, 80, and I've moved it over here. So now it's on this side of the equation. And instead of adding two numbers together to get 80, I need to find the difference between this number and this number that is equal to or the same as 80. So I know that 96 minus 16 is 80. So 80 plus 16 equals 96. So it may seem a bit obvious. It may be like, well, Mr. Kilpatrick, I can just solve this number sentence straight away and put a 96 in there. You could, but today that's not really the focus. It's about applying the inverse operation, and I'll show you why later in the lesson, why that's really important. So go through this process of applying the inverse operation, representing what it would look like in the inverse here, and then solving it. Here we've got 125 divided by 5 equals something. So again, I'm going to apply the inverse operation. So I've moved this number here, 125, to this side of the equation. So I'm going to cancel this out, and I've put this over here. And actually, instead of cancelling it out, I've actually brought it over here. So I'm kind of switching places, yeah. So now I've got something times 5 equals 125. Well, I know that 4 times 25 is 100, and another 25 is going to be 125. So it's going to be 25 times 5 equals 125. So 125 divided by 5 equals 25. Again, using that inverse operation. So here, because I've moved it to the other side of the equation, I have to apply the inverse operation of division, which is multiplication. And now it's going to be something times 5 equals 125. Okay, now we've looked at some basic equations. I thought I might show you why this is particularly relevant for more complex equations later down the line, this understanding of inverse operations. So let's say we've got this equation here and it's saying solve for y. So it's saying find out what the value of y is. It's the equivalent of y would just be like, a square, for example. So let's say we've got 5y, which means 5 times y plus 9 equals 44. So what I'm going to do first, I'm going to use my knowledge of inverse operations, and I'm going to subtract 9 here. And then because I'm subtracting 9 here, I'm also going to subtract it from this side here. So I'm doing the inverse. So I'm cancelling this out. And now I have 5y equals 44 minus 9. So I know that 44 minus 9 is 35. And then now I've got 5 times y over here equals 35. And I know the opposite of, or the inverse of multiplication is division. So I'm going to divide each side by 5. So 5y divided by 5 and 35 divided by 5. So now I've found my answer. I've ended up with just y here. And on this side, I've ended up with 7. So it tells me that y equals 7. And that's my answer. Now I can actually test that out by inserting the 7 in here. So I can say that 5 times 7 plus 9 equals 44. So 35 plus 9, and I know that equals 44. So that's why this knowledge or understanding of inverse operations is so important. Today we've got some really basic examples, but further down the line, when you start doing algebra, having that knowledge of being able to do the inverse of something and actually break it down is so important. And here are your main ideas from today's lesson. The first one is that inverse operations are operations which are the opposite of one another. So our main inverse operation relationships are addition and subtraction. So they're two operations that are the opposite of one another, and multiplication and division. They are the opposite of one another. They undo each other. Using inverse operations can help us justify an answer to an equation. So that's what you're looking at today. Here, for example, we've got 105 divided by 7 equals 15. And I know this because 15 times 7 equals 105. And lastly, it can also help us find unknown values in number sentences or equations. So we saw that example, or the three examples before, and particularly that last example where we had the letter y, where we didn't know what the value was there, the number. We used that knowledge of inverse operations to find the value of y there. Now, you're not doing that today. That's just to show you why this is so important to understand that inverse operations can be used in these different contexts. Okay, thanks very much today, and I'll see you tomorrow. Good morning, everybody. Welcome to your Maths for Week 6, Lesson 3, Year 5. Today we are looking at number sentences with decimals and fractions. So today you're learning to solve equations, which we know are a type of number sentence with an equal sign in them, that involve decimals and fractions. Now to do this, you'll really need to understand your place value around decimals. So understanding what differentiates each place value, and that still applies to our regular place value system, but particularly with decimals, what's the difference between this 2 here and this 2 here. Also, you'll need to recognize the relationship between division and fractions, which I'll go through. Once you've put your answer into the equation to make it balanced, you'll need to check it. And then lastly, if you can, check your answer using the inverse operation, and I'll also go through that in a moment. Now let's look at our decimal system before we start looking at number sentences involving decimals. The first really important thing to realize is that each of these place values is separated by multiple of 10. So here we've got our ones, which are our whole numbers. So that's, let's say we've got 3, so that's 3 wholes. And here we've got decimal places, which are less than a whole. They're still a number, but they're less than a whole. So let's say we have 3/10. So to get to 3 ones from 3/10, I'd need to multiply it by 10. And then I'd have 3 ones. If I wanted to get to 3/10 from 3 ones, I'd do the inverse or the opposite, and I'd divide it by 10. Now, if I had 3 ones and I wanted to get to 3/100ths, instead of dividing it by 10, I'd need to divide it by 100. So it'd be divided by 10, and again divided by 10. Now 10 times 10 is 100, so I can just say that's divided by 100. So it's really important when you are trying to solve these equations that you recognize that there are differences between each of these place values here of times 10 or divided by 10. Times 10 if it's getting bigger, divided by 10 if it's getting smaller. The other thing that's really worth noting is that let's say we have 4 and 1/10 and 200, so 4.12, and I multiply this by 2. Each of these place values is going to be multiplied, so the 4 will be times by 2, so that becomes 8. The tenths is times by 2, so that becomes 2, and the hundredths is times by 2, and that becomes 4. So it's really important that when you're multiplying or dividing by a number and you've got decimal places, that those are also operated on by that operation that you're doing. Same, let's say we'll rub this one out. This is for multiplication and division. Let's say we have 3.69 and I'm dividing it by 3. So here this would be 1. This would become 2 because 6 divided by 3 is 2. And this would become 9 because 9 divided by 3 is 3. So it'd be 1.23. Okay, here we have some equations with decimals and they have some missing values or missing numbers. Now my first one is 6 times something equals 0.66. Now I know that when I'm multiplying with decimals that each of these place values here, so the tenths and the hundreds, are also operated on by this multiplied by 6. So I might know that 0.11, so here I'm saying 6 times 0 is 0, 6 times 1 is 6, and again 6 times 1 is 6, so it's going to be 0.66. Now to show that with an inverse operation, what I can do is I can say, well, 0.66 divided by 6 is equal to 0.11, because in this case, instead of multiplying these ones by 6, here what I'm going to do is I'm going to divide these 6s, so the 6/10ths and the 6/100ths, by 6, and so I end up with 0.11. Here for B, we have something divided by 10 equals 1.75. So here, knowing when I divide by 10, I need to move my decimal point. So let's say I've got 17.5. I'd move my decimal point this way because the number is getting smaller, and move it to the left. and it ends up with 0.75. Now, if I wasn't too sure about that, I could use the inverse operation and say that 0.175 times or multiplied by 10 equals 17.5. Because in this case, instead of moving it to the left to make it smaller, I would move the decimal point one place to the right. So it would end up becoming 17.5. Now this last one here, again, kind of relies on our knowledge of decimal points and those place values being separated by, multiplied by 10 or divided by 10. Same with the rest of our place value system. So here we've got 10 times something equals 5. Now what I could do is I could say, if I don't really know the answer to this, I'm going to invert it. So I'm going to say my answer here, 5 divided by 10 equals 0.5, because what I've done here is I've got the decimal point and I've moved it one place to the left because I'm making it smaller, and so it's ended up being 0.5. So here I can say that 10 times 0.5 equals 5. And in each of these instances, I've used the inverse operation to justify my answer, and I might have even used it to help me find the answer. Okay, now let's look at some fractions facts that will really help us with our equations involving fractions. So here I've got a fraction. My numerator is 3 and my denominator is 5, so I have 3/5. And you might recognize, that's what this looks like in a diagram. I've got 3 parts here shaded of 5 green parts. Now, I also know that I can represent 3/5 as 6/10. So here, what I've done is I've actually multiplied the 3 by 2 to get 6 and the 5 by 2 to get 10. And again, I've got an equivalent fraction, or the same fraction. So even though they're different numbers, the same proportion or the same amount of this bar is shaded yellow. So they are equivalent, they are equal to one another. Now here I've got 6/10. Now, if you remember with our decimals, we also have a place value called tenths. So 6/10 is equivalent or the same to 0.6 or 6/10. Now, this is all very well and good, but the one thing I want you to take away from today is that this fraction here, 3/5, is also the same as writing 3 divided by 5, which if I used a calculator would give me the answer of 0.6 or 6/10. So the main fractions fact to take away from this is that a fraction itself is like a self-contained division problem. That means that the number on the top, let's say I've got 5/7, is the first number in the number sentence. Then this line here, which is called a vinculum, is like the divide sign. And then the denominator, the bottom number, is the second number in the division number sentence. So here we've got 5/7 is the same as 5 divided by 7. And you'll see in a moment how that's really powerful when we are solving equations with fractions. The other thing I'd like to look at with fractions, apart from them being self-contained division problems, so what I mean by that is here we've got 1/4, so it'd be 1 divided by 4. What I want to look at is what happens when we multiply a fraction. So here by a whole number. So here we've got 1/4, and you can see that I've represented it by dividing this bar into 4 equal parts, and one part is shaded yellow. So if I want to multiply 1/4 by 6, what is going to be my answer? Am I going to multiply the numerator and the denominator? So then I would end up with 6/24. Well, as a matter of fact, I'm not going to do that. The only number I'm going to change is the numerator. So let's say I've got 1/4 here, and I want to multiply it by 6, so I want to have 6 1/4. It would look like this. I'd have my 6 bars, and I'd have each of them with 1 shaded in. Now I can simplify that into a mixed numeral, but if I kept it as an improper fraction, it would look like this. It would be 6/4, and that's exactly what I have here. So when you're multiplying a fraction, the only thing you need to think about, by a whole number I should say, is changing the numerator. So here, let's say I have 10/12, and I multiply it by 2, I'd end up with 20/12. Okay, let's look at some equations with fractions. So this equation here, it's got a missing value at the start. Something divided by 7 equals 2/7. Now I know that fractions are self-contained division problems. That means that the bottom number, the denominator, is the divisor. So here I've got 7, which is going to be the number I'm dividing by. And the top number, the numerator, is the number that's being divided. It's the dividend. So here it's nice and simple. All I need to do is put the 2 here. So 2 divided by 7 is equal to 2/7. Now I can actually prove this using an inverse operation. So what I'm going to do is I'm going to put the 2/7 at the start of my equation. And then I'm going to do the inverse of division, which is multiplication. So I'm going to multiply by 7. Now, when we multiply a fraction by a whole number, we only need to change the numerator, the top number. So here, 2 times 7 is 14, which gives me 14/7. And again, remembering that a fraction is a self-contained division problem, the top number is the dividend, that's the number that comes at the start. 14 divided by 7 equals 2. And there you go. Now let's look at this one. 2 tenths times something equals 8/10. Well, I know that when I multiply a fraction by a whole number, only the numerator changes. And here, the only thing that's different between the 2 and the 8 is the numerator. Now I know there's a relationship between 2 and 8, that 2 times 4 is 8, so it's going to be 2/10 multiplied by 4 equals 8/10. And lastly, I've got 1/8 times something equals 1. Well, we know that fractions are parts of a whole, and here I've got 1/8 of a whole. So if I have 8 1/8, I'm going to have a whole. Now we know we represent a whole using 1. So here I'm going to have 1/8 times 8 equals 1. And I can actually prove this by saying, well, what we'll do is we'll make this 1. We'll move this 1 up to the front. And I'll do the inverse of multiplication here. I'm going to do divide by 8, which is 1/8. And there you go. Okay, and here are the main ideas from today's lesson. So the first one is around decimal places. And because we use a base 10 system, it means that our place values, this goes for our 1s, our 10s, and our 100s, but also for our decimal places, are separated by powers of 10. So for example, the difference between 0.3 and 0.03 is dividing by 10. Or here we've got 0.07, multiply that by 10 becomes 0.7. Now you might remember this is where we move our decimal point like this, so that'd be 1/10, 2/10, and so on. The same applies for whole numbers as well. The difference between 2 and 2/10, which is 20, is 10. Or 2 and 200 is 2 times 100, which is actually 10 squared. It's a different term of power of 10, but it's a power of 10. Also, when we're multiplying or dividing, Make sure that you apply that to the decimal places as well. So here, nice and simple, we've got 2 times 2.41. I just need to multiply each of these places. So the 2 becomes a 4, the 4 becomes an 8, and the 1 becomes a 2. And I keep my decimal point there, obviously. The other big piece of news from this lesson, which some of you I'm pretty sure are quite familiar with, is fractions are self-contained division problems. So here we've got 7/3. It's the same as 7 divided by 3, and we saw how that was true with another example. So this bottom number, the denominator, is the divisor, and the top number goes first. It's the dividend. That's the number being divided. Second last, multiplying a fraction by a whole number, only the numerator changes. So here, 1/3 times 7, I only need to change this top number, so my answer is 7/3. And lastly, make sure you check your answer by putting it back into the equation, or you could also use the inverse operation where you know how. Okay, good luck guys. I'll see you tomorrow for the last lesson of the week. Hi everybody, welcome to lesson 4 for week 6 for year 5 maths. This is your last lesson or video lesson for the week, I should say, because tomorrow you'll have the science day activities, so you won't have any maths on tomorrow. Okay, so today in our lesson we're learning to solve word problems that require finding a missing number. So it's all kind of wrapping up with word problems. We've been looking at equations this week, which are number sentences involving an equal sign, and trying to balance each side of those so that we get the same amount on each side. Now, in some situations, we've actually had a missing number and we've had to figure that out, and we've used our inverse operations to help us with that. So today we're going to be using some of that. The first thing to do this correctly is you need to be able to write the word problem as a number sentence or an equation. That's the very first thing. You want to make sure that your word problem is accurately represented using numbers and symbols as a number sentence. Then you want to use a symbol. Now today we're going to be using this black square to represent an unknown value. Now in the other lessons and activities this week, we've just kind of left a space there. But today, I think it's going to be more useful to use this black square. That's our unknown value, which we will find at the end. Then you're going to use inverse operations to simplify your equation. Now I'm going to explain that a little bit later, but we've kind of been doing it this week already and using it to justify our answers, but today we're going to use it to simplify an equation because some of these are a little bit tricky. You'll see what I mean in a moment. Next, you're going to show your working out. Oh my gosh, this is the most important part of today's lesson out of anything. I'm going to show you a few tips and tricks for that. But it's really important that you show your working out. It's not a case of just writing the number sentence or working it out in your head. Throughout this week, it's really important to be able to justify your answer by showing your working out. And lastly, which I'll also go through, is making sure that on each line of your working out, the equal sign lines up. So you're going to have more than one line of working out. So you're going to have several lines of the equation as you work through it, and you want to make sure that the equal sign lines up. So I'll go through that in a moment. Okay, so here's an example. Now I've actually included this example in your activity today. So if you forget this, you can refer back to it to kind of help you work through some of the other word problems. But here we've got Yusuf thinks of a number. So there's a whole lot of students' names in there and they're all thinking of numbers today. Yusuf thinks of a number, adds 3 to it, and then multiplies it by 4. So this number he's thinking of is our unknown number, which we're going to represent using a square. He adds 3 to it and then multiplies it by 4. His answer is 20. What is Yusuf's number? So for step 1, what I'm going to do is I'm going to write out this word problem as a number sentence. So write my equation with the unknown as a black square, and here I've got black square plus 3. Now I've actually surrounded this with brackets because I want to note that I do this part first. Now this is really important for something called order of operations, which we'll look at later. But for today, that's what I'm doing. I know that I do this part first, and then I multiply by 4. So here, the unknown number plus 3 multiplied by 4 is equal to 20. So as we work through this, we want to make sure that this side here balances is equal to this side here. The next thing we're going to do is we're going to cancel this times 4 by doing the inverse operation on the other side of the equation. So we know the inverse of multiplied by 4 is divided by 4. So what I'm going to do is I'm actually going to cancel this side and I'm going to divide this side by 4. So let's have a look at what that looks like. So now I've got square plus 3 equals 20 divided by 4. And I'm going to do that. So 20 divided by 4 is 5. So something plus 3 equals 5. And you see, as I've done that, I've just simplified this. So I've actually removed one part of the equation. Now we're down to these 3 parts here. Then what I'm going to do, like I did with the multiplied by 4, I'm going to do that with the plus 3. I'm going to cancel this out by doing the inverse operation on the other side. So take away 3. So now my answer is, or my equation is, square equals 5 minus 3. And we know that 5 minus 3 is 2. So the black square is equal to 2. So Yusuf's number is 2. Now I could test this out by saying, okay, let's put it into the equation. So do my bracket sign, 2 plus 3 times 4 equals 20. And now I know I do this part first because it's in the brackets. Now I didn't actually do this part first when I did the cancelling, but when I'm solving it, that's what I do first. So 2 plus 3 is 5, and 5 times 4 is 20. So both sides of the equation balance, it's correct, it's true, and we are good to go. So that's the steps that I've followed. Now what I'm going to show you is the working out and how to set out your working out, because you don't need to write all of these steps. That's just to help you. Now I'm going to show you how to set out your working out. So here we've got that same problem. We started with our number sentence at the top. And on each line as I go down, as I'm simplifying this equation, this number sentence, I'm making sure that my equal sign lines up. This is so important. It also kind of gives me the sense that each side is balancing all the way through. If it's kind of the equal signs down here and then down here, it's kind of all over the place. My main aim is, one, to simplify this and to try to solve it, but also to make sure that at every stage throughout this equation is balanced. That's why I did my inverse operation on this side. Kind of cancelling out this 4 because I'm doing the opposite on this side here. So it's the inverse. And we kind of looked at that earlier this week on Tuesday about doing the inverse operation to find an unknown value. Let's look at one more example. Mrs. Zato says, I'm thinking of a number. That's going to be our black square. We don't know what the number is yet. I divide it by 5 and then add 9. My answer is 17. What is my number? So step 1, I'm going to write the equation or the number sentence with the unknown as a black square. So it would start off with the black square. I'm going to divide it by 5. So here, add 9, equals sign. Now we know that the equal sign doesn't just mean the answer. I know I've been saying that all week. It means that this side of the equation is balanced to this side, but for all intents and purposes here, we're going to put an equal sign and it's 17. So whatever all this stuff happens at the front is equal to, or it's the same as 17. Then my step 2, I'm going to cancel this plus 9 here by doing the inverse operation, so minus 9. So I'm going to take away this 9 here. And because I'm doing it there, I'm going to do it also over this side as well. So I'm going to have square divided by 5 equals 17 minus 9. So I've kind of cancelled it on this side because I've taken it away. So I'm going to also take it away from this side as well. So now I have square divided by 5. And I know 17 minus 9 is 8. Now you might already realize what the answer to this equation is already, but what I want to do, what I want you to do is to go through and simplify it to the point that all that is left is this black square on one side of the equation, the equal sign, and then a number, an answer on the other side. So for step 3, I'm going to cancel this divided by 5 by doing the inverse operation here. Yep. So now I'm going to do the inverse operation here. 8 times 5, so this has been cancelled, this is gone. Now we're doing it on this side, 8 times 5. So square equals 8 times 5 now. And we know 8 times 5 is 40, so Mrs. Sato's number is 40. And just to show you what that looks like with the working out, here we've got the working out, the equal sign all the way down. They're all in line with one another. And I've always kept this black square on this left-hand side. So I've been simplifying. I've basically been getting rid of this stuff using inverse operations to isolate the black square. So it's by itself. And then because I know that an equation is balanced, that will tell me what the answer to the black square is, what this black square actually means. And we've realized, well, if this side equals 40, we know an equation has to balance. We know it has to be the same on each side. So this side must be 40 as well. Okay, and to sum up for today's lesson, here are the main ideas. So write the missing number problem as an equation. That's the first thing you need to do. And remember, today we've been using this black square as the missing number. Then for the equation, you can cancel an operation on one side of the equation by doing the inverse or the opposite operation on the other side of the equation. So the other side of the equal sign. So let's say here I've got square times 4 plus 2. What I can actually do is I can say, well, do you know what? I'm going to cancel this plus 2 here, so get rid of it there, by doing the inverse operation on this side, which is minus 2. So then I would have square times 4. Now we should try to keep these in line with 26 plus 2, also 26 minus 2. And then I'd carry on for the rest of my equation all the way down. Now make sure you show all your working out and keep the equal sign in line with one another on each line of your working out. So I should have done this a little bit better, but my equal sign should always be in line with one another as I'm simplifying this equation. Make sure you simplify it to the point where all that is left is the unknown value on one side. So remember, we got to the point where we had the black square on one side, the last one, and then we had the other side was 40. So that will tell us that, well, this black square here has a value of 40 because we know that an equation has to be balanced. And then you can check your answer by putting it into the equation. Now, I didn't do this with the last one, but I did it with the example involving Yusuf's unknown number. So make sure you do that at the end, just to make sure you haven't made any errors along the way. It's a really useful way of checking that you've got the right answer at the end. Okay, guys, I hope you've enjoyed this week's lessons. It's a lot to take in, but this is really important stuff. It's really interesting and it will serve you well once we move on to kind of more algebraic thinking and trickier equations where we've got these missing values. Okay, thank you very much. Goodbye.